Hi class, this is Course 2, Lesson 80, Transformations. Transformations will preserve congruency, and what that means is that the shape will stay the same size. The orientation, or where it is located, will change, but the shape will always be the same size. The movement for these transformations, we have flips, which is called a reflection, a slide, which is a translation. Whoops, I X'd out the wrong A. I copied that right out of the book, and for whatever reason, they have it typed incorrectly on my paper. So a slide is a translation, and a turn is a rotation. And now here's a handy way that you can maybe remember these terms, because you might be asked to give the name of the transformation and you might not be able to remember them. But flip starts with the FL, and there's an FL in reflection, and slide has an SL, and if you spell it correctly, so does translation. And turn and rotation, I guess you're just supposed to know that that is a rotation. There's no handy way for you to remember that. But I think that one is the easy one. You are familiar with turning and rotating, meaning the same thing. Now a flip, or what we call a reflection, that's going to produce a mirror image, and they'll be reflected over lines. So if you put a mirror down on the line, it's what the image would look like, and we'll go through examples of these here in just a minute. A translation is going to slide the object without turning or reflecting it. So simply we are just moving it to a new place. And a rotation is going to turn a figure about or around a specific point. Now a dilation is going to change the size, which does not preserve congruency. This is how we get similar figures, is through dilation. These are enlargements or reductions, and they will use a scale factor. Okay, so let's get right into it. We are going to plot the points. So we have vertices of triangle, RST, and those vertices are located at R, 4, 3, at S, 4, 1, and at T, 1, 1. So we would simply plot those points and label them accordingly to the points for that triangle. And then we are going to draw a triangle RST at its reflection in the x-axis. Okay, so it's being reflected or flipped over the x-axis. So reflection in the x-axis and flipping over are the same thing. So the x-axis is here, and so we have to put this triangle down here, and it has to flip over it. When you graph these, if you fold your paper on the line of reflection, then that will help you see where those points should lay out. When you fold the paper together, they should line up identically. Okay, so when we flip those, here's what I do. Just to look at these really quickly, I go over to 1, and then I went up 1. So to reflect, I would need to go over to 1 and then go down 1 instead, because it has to be the same distance away from that line of reflection that the original is. Okay, so we would do that with all of those points, and this is what our image is going to look like. Okay, so this is the object, and this is the image. Okay, the image, do you see how the points are R, S, T? It has those little lines. When you see those, you say R prime. That little apostrophe, I guess, is called prime notation, so that we know that that is the image. So it's R prime, S prime, T prime. And you might be asked to provide the coordinates for those, and you would just list those. Okay, here's another example. This is a rectangle ABCD. It gives us the vertices, and we plot those points. And you label them with the A, the B, the C, and the D. Now we're going to draw, well, we already drew that triangle or rectangle, and its image, A prime, B prime, C prime, D prime, translated to the left 5 units and down 4 units. So this one, it's like we just pick the rectangle up and we move it over 5 and down 4, and that's exactly what you would do. And you would plot those new points and label them A prime, B prime, C prime, D prime. Here's another example. The coordinates of these vertices for this triangle P, Q, R, are P at 3, 4, Q at 3, 1, and R at 1, 1. So we plot those points. And then we are going to draw its image, triangle P prime, Q prime, R prime, after a counterclockwise rotation of 90 degrees about the origin. Okay, so there's a whole lot of information going on in there that we need to be aware of. First off, we're going counterclockwise, so that's against the clock. So we would be rotating in this manner. 90 degrees, that's a quarter turn. And about the origin means that our center that we're going to spin it around is right here. So we are going to, in effect, we are going to pick this triangle up and we are going to rotate it 90 degrees and put it over here. So we picked it up and we spin it. And these can be kind of tricky to figure out. And then we would label it so it looks like this over here. P prime, Q prime, R prime. Notice that point P goes to this point up here, P prime. These can be kind of tricky. What you can do is, spin your book to see what it might look like when it's rotated. You can borrow somebody else's paper to rotate it. Flip the page, kind of memorize how it looks, turn it back. They can be tricky, but after a little practice, you'll be fine. Okay, one more. We have to go through the other transformation that we have, which would be a dilation. So we're going to take triangle XYZ with its vertices that we've plotted. We're going to make the dilation of the image of triangle XYZ with the center of dilation at the origin and with a scale factor of 3. Okay, because the dilation goes from the origin, we know that we just take the scale factor of 3 times each of the coordinates to get the new coordinates x prime, y prime, and z prime, which would be 3, 3, 6, 3, and 3, 6. So as long as you have the dilation centered at the origin, you take the scale factor and multiply it times your original coordinates, which would then allow us to plot these points, x prime, y prime, z prime. Notice that it is twice as big, or 3 times as big, sorry, as the original. Now, if your scale factor is less, between 0, if your scale factor is between 0 and 1, you will get a reduction because you are shrinking it. Okay? That's all I have for you today. There are a lot of vocabulary terms for you to memorize: reflection, translation, rotation, dilation, but also how you perform those transformations. Okay? You'll work the practice set in class, so if you have questions, that'd be a great time to ask me. I'll see you then.